All right, I'm going to try to match the energy. That's hard. I need like 3 cups of coffee for that one. So today I'm going to talk about BioM. Just double click on what Jason mentioned about building AI, okay? So we mentioned agentic AI. People probably have heard about these terms. I think I went to the Agentic AI Summit in Berkeley where OpenAI engineering director said, we thought agentic AI 2025 was going to be agentic AI. The year of the agentic AI is what he said. But he said, I was wrong. We were wrong. Okay? Why? It's not because this technology doesn't have potential. It's because there's a lot of work, a lot of toolings have to be there for this to work. Okay? And even OpenAI didn't anticipate it. They played around and they're like, okay, there's more work to do. Okay? How many of you guys have heard OpenClaw? Yes. So I think 2026 is going to be the year of agentic AI, right? But the really neat is the gap between adoption intent and deployment success. A lot of actually complexity in building agentic AI. I would say probably one in prompt engineering aspect of things, and then in orchestration of agents aspect of things, right? So in this talk, I'm mostly going to talk about prompt engineering. In the tutorial, we're going to go into a little bit about orchestration and the architecture of agents as well, too. So you guys have all done prompt engineering, I would assume. How many of you guys done prompt engineering, agentic system? OK, all right. So here's a very simple example. It's not even quite agentic. Think of it as one agent, really simple example. I have some code, and I just want to this is a Python code for Pygame, using Pygame library, but basically building a game, okay? So this is the data structure of the game. So I have position, the wall, so there's a map, they're trying to do the level. I'm assuming I have gamers in this crowd, so I don't have to explain what a level is, okay? I had to for some professors. Anyway, so now I want to actually do a function called getNextLevel, which is generate the next level for me, okay? Without AI, this is where you have to hand code the business, how to generate the next level, right? So you have to get a designer, you have to figure out, you maybe actually have to have a pre-stored, design the level stored or whatever, right? So that's old school, but of course I say, nowadays people can just use AI and they figure out how to actually get LM to generate the level for you, right? The sad thing, however, is you need to do a bit of a plumbing when you actually do that, right? How do I really get LM to get you the next level, right? I have to talk to LM. I have to make it understand what I want. It's a game level. I have a bunch of actually data structures and types I need the LM to understand, generate, and give me the correct output, right? So that's really what prompt engineering is, right? We do it, we don't like it. I don't think anyone says, I enjoy my job of prompt engineering, okay? It's click, 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 try, click, 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 try, click, click, try. If you run any regression testing on that, you'll be like crying and be like, I just changed one word, what the heck? All right, anyway. So I could go in there. So you're going to design the prompts. You're going to say your game level, give me a valid JSON, please, right? Whatever, prompt design. Then you have to be like, OK, articulate my output format specification in the prompts. Then I have to do a bunch of output validation code, right? So I have to be like, check if LM gave me correct output. If not, I have to try it again. I have to figure out the error handling. So all of this is a simple function, right? But you have to hand code hundreds of lines of code. So if we have cursor people in the actually audience, you could ask them how many lines of prompts they actually put into the system, how many lines of prompt that's lovable put in their system. There's some of this that actually was released. I don't think it's Cursor. Which company was released, actually, the prompts, which leaked out, actually? I don't know. I don't remember, but hundreds and hundreds and hundreds of lines. All right. So what if we have another way to do this, right? We're here. If you join the track for agentic AI, you're going to have to solve that problem or just try to figure out, what if we can do this automatically, right? All right. I don't even know if the young crowd actually know the reference of the movie, but You know, right? Anyway, so we want to do this actually automatically. Here's a bunch of theses. This is for academics. But essentially, you could read it like in the simple words. If a developer writes software, they typically write the software in a way that you could read the code, right? But if the human can understand it, then LM can understand. So you really, in other words, you could extract the developer intent just from the code it actually writes, right? And if you actually look at the code and say, hey, I want a function called getNextLevel, I kind of read your code and understand what you want to get from this getNextLevel function, LM can too, right? So you really don't have to actually restate those intent in your prompt text format. It's already embedded in your code, okay? So you just need a system to automatically extract those semantics and give it to LM. Here's more example of how this is done. If you read the code such as, okay, DOB string blah. A developer can read this. You could understand it. LM can read it and understand what you're trying to say here for that particular string, right? All right. So this is what we actually come up with, which is instead of doing this way, hand code, or do the prompt engineering you've just seen actually earlier, we're going to make it as a one line in your code. And this is the power, actually, when you design AI native in your programming language, we have one keyword called by. Okay, this particular keyword can be used in function calls, can be used in object initialization, but basically it tells the compiler that I'm ready to use LM for this particular function, make it happen. Okay, so how does it make it happen? Details. This is all under the hood. You don't have to know when you use it, but the compiler is going to extract semantic information. So it's going to function signatures surrounding all the type information hierarchies. It's going to pack it into this intermediate representations, and then it's going to give it to the runtime. When you run this code, the semantic information, we're going to take it together, generate the prompt for you, handle the object, output, and also have error handling. So everything under the hood, you don't have to know. All you need to know is this magic word that you use that will solve your prompt engineering problem, okay? And I'm going to skip this too because that's the compiler thing. I don't know how many of you guys have taken compilers before, but anyway, blah, 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 we'll give you a prompt, okay? All right, so we did actually a bunch of analysis. This is a paper that's published, so you have to do the graphs to show how good you are. DSPI is still what Jason mentioned. LMK also actually Jason mentioned. So this is the lines of code changing that you need to do for us, really, because all we need to do is really putting by keyword in, and all the other toolings you require a lot of actually sort of either writing the prompt or worry about output handling. So how accurate, this is probably you actually guess, try to see. So we're very, very accurate, close to 100% in a lot of actually cases. And this is the benchmark that DSPY used. How sensitive to your bad coding names. If I just name your thing my value or foo everything, that's not great, but you probably shouldn't code that way either, okay? But it's actually relatively okay. This is 50% of your variables are bad names. We're still actually relatively accurate, okay? Bunch of numbers. Who could use this? Everyone, because it's on GitHub. And I want to mention that we launched this in October, and this is our daily downloads actually number. So it's getting a lot of popularity over the last 2 months. And we add a lot of innovation on top of that. So for this particular track, we also provided this thing called SAM-string. So basically, if you're building an agentic system, this is the content generation system. We have supervisor, planner agent, writer agent, review agent. And Biome can generate all the prompts for you, all the function calls within those agents. But if you also want to provide even more constraints or actually your thoughts or intent, you could use a very lightweight, we call it a SAM-string annotation for that. So you could actually just say, hey, I just want the first initial stage to be planning, okay? And this is actually a lot easier than adding hundreds of lines of prompts, but you could actually lightweight by one line give that particular information. All right, future work, we're actually building out a pretty crazy roadmap in terms of auto-generating tests based on the code, do the prompt CI for you, so you could actually have regression testing for your prompts, and also dynamic evolution to improve your prompts based on dynamic execution. So those are the work that we're actually building out on top of this toolchain. I think this is the last slide. Hopefully that give you guys a little bit insights on what we're doing. And if you join the track, we could talk more about the prompts and the agentic AI stuff.